So good afternoon, everyone. Welcome to the class on statistics, where probably till now what we have done so far till now in statistics, we discussed about unweighted index number methodology. We have discussed about them. Okay, we discussed about them unweighted price index number methodology. Okay, where what we have done. So you know that, right? Index number can be price index number, it can be quantity index number, it can be value index number. You know the theory part. We have discussed a lot about theory. So we have discussed so far unweighted price index number methodology, where first we discussed about the simple aggregate method. You know the formula of simple aggregate method. If I talk about price index number, so simple aggregate method, imagine the formula for the simple aggregate method will be sum of P1 by sum of P naught into 100. So sum of P1 by sum of P naught into 100. This is price index number. Imagine if you would be using quantity index number, then your formula would have been sum of Q1 by sum of Q naught into 100. Where P1 is the price for the present year, P naught is the price for the base year. You got getting it right. So if you use simple aggregate method, then this will be your formula here. When we talk about price index number, we'll take only the current year price and we'll compare with the base year price. If we talk about quantity index number, then we'll take current year quantity, we sum of current year quantity, and we'll divide by the base year quantity. This we have done already. We have done numerical, which I believe you have understood very well. Similarly, we discussed about price relative method, simple average of price relative method under the unweighted index number methodology. Here, first thing, no, whenever you use price relative method, unweighted price relative method, the first thing what you need to do, you need to find the price relative. The first thing what you need to do, you need to find the price relative. So if you are using price, if you're using price index number, then you will find first thing price relative. Imagine if you would be talking about quantity index number, then there we would have found quantity relative. So price relative, that would be P1 by P naught into 100. So for each year, you can find P1 by P naught into 100, which we'll call as P. Okay, and then for the simple relative method, where if you talk in the term of arithmetic mean, so simple average of price relative method for arithmetic mean, if you use, then your formula will be sum of P by N. Okay, and then it will give us the answer. Similarly, if you use simple average of price relative method by using geometric mean, okay, then you'll use simultaneously similar formula, where we'll take the help of log and anti-log. So your formula is log of sum of log P. So you can write other way, anti-log of sum of log P by N. Anti-log of sum of log P by N. Okay, so we have done numerical based on this. I believe you people are very clear with this numerical. Fine. Then we have done this. I think last two classes we are discussing this only, how to work on log, anti-log and all. So this part you're clear. Now in today class, I'll start the weighted aggregate index number. Okay, till now we did unweighted aggregate index number. We talked about unweighted average of price relative method. Now in today class, we are starting with a weighted aggregate of index number, where different methods are there under weighted aggregate of index number. If you follow, we have different methods, like we have one method called Lasperus method. Okay, all these are very important for exam perspective. We have Lasperus method, then we have Paasche method, then we have Fisher ideal index, then we have Dorvis-Wally. So many book it is written Wally method, some book it is written Dorvis-Wally method, some book it is written as Dorvis-Wally method. Okay, then Marshall Edwards method, then Kelly method. So these are the 6 methods we need to remember here. Whenever we are here talking about the weighted aggregate index number method, so we need to study these 6 methods. We need to talk about Lesperus method, partial method, Fisher ideal method, ideal index method. So ideal index method. Why Fisher is called as an ideal index method. If you have basic knowledge statistic, you can easily answer this question. Fisher, out of all these methods, the most appropriate method, the ideal method is called as Fisher method. That's why many textbook and all, if you read this Fisher method written like Fisher ideal index method, Fisher ideal index method. It's written as Fisher ideal index method. So when you talk about Fisher ideal index method, Fisher ideal index method is one of the method which follow both time reversal test and factor reversal test. What are time reversal test? What are factor reversal test? That I will discuss with you in future. But time reversal test, factor reversal test are very important for your exam perspective. So here, if I'm using Fisher method, we call this a Fisher ideal index method. So we have something called we have other method like Dorgus-Bowley method. We have Marshall-Edwards method. We have Kelly method. So these are 6 methods are there. So one by one, I'll tell you the formulas of this method. I sincerely request everyone to make a note of the formula. They're not at all difficult. Only thing is that you need to work on that is the minimum thing what is expected from you. You need to work on the formula. So Lesperus method, this is the formula for Lesperus. Very simple. So sum of P1 Q naught divided by sum of P naught Q naught into 100. So I hope you are getting know what is P1 Q naught, all that. What is P1? P1 is the current year price. No? I hope you remember. So current year price. So you'll multiply the current year price with the base year quantity. So you'll multiply the current year price with the base year quantity. Okay, multiply them and take the sum of that. You're getting sum of P1 Q naught. Then sum of P naught Q naught means base year price with base year quantity. Take the sum of that. So this way, when you do calculation, this is called Lesperus method. Okay, we'll do numerical for that. Don't worry on this. Just write down the formula for the time being. Okay, so this is sum of P1 Q naught. This is sum of P naught Q naught, not P Q1 P naught. P naught Q naught. Okay, this is Lesperus method. Okay, everyone. This is called Lesperus method. Okay, then after Lesperus, after Lesperus, you have partial method. You have partial method. This is partial method. So these are just the method name. Sum of P1 Q1 divided by sum of P naught Q1 into 100. This is partial method. What is P1 Q1? I think you know very well. P1 is the current year price. Q1 is the current year quantity. P naught is the base year price. Q1 is the current year quantity. P into Q is called expenditure. Price into quantity is called expenditure. I hope everyone knows this formula, right? Everyone understand this. Expenditure is equal to price into consumption. Price into quantity also you can say. Which is equal to price into quantity. Clear, everyone? So you understood what is Lesperus versus partial. You can see this P naught is the price for the base year. P1 is the price for the current year. Q naught is the quantity for the base year. Q1 is the quantity for the current year. Clear, everyone? So once you calculate the Lesperus, once you calculate the Lesperus, once you calculate the partial, once you calculate the Lesperus, calculate the partial, then the geometric mean of Lesperus and partial is called Fisher ideal index method. So you need to find the geometric mean. If you can find the geometric mean of Lesperus and partial, that is called as Fisher ideal index method. Are you getting me? Geometric mean, are you understand? What is the geometric mean? What is the geometric mean? If I ask you what is the geometric mean of A and B, What is the geometric mean of A and B? If I ask you what is the geometric mean of A and B, the answer will be root AB. So you find Lesperus index number, you find Paasche index number, multiply and take the root of that. That we call as Fisher ideal index number. Fine. Lesperus, you know what is the formula of. So Lesperus index number formula, sum of 1 Q naught divided by sum of P naught Q naught into 100. This is Lesperus. Paasche index number formula, sum of P1 Q1 divided by sum of P naught Q1 into 100. This is Paasche. So you have Lesperus, you have Paasche. Multiply them and take the square root of that value. That is called Fisher ideal index number. Clear, everyone? So we are talking about right now weighted aggregate. We have discussed already about unweighted aggregate index number method. Right now we are talking about weighted aggregate index number method, where we have different methods. Like we have Lesperus. This is a formula of Lesperus. Then we have Paasche. This is a formula of Paasche. You multiply them and you take the square root of that value. That is called Fisher ideal index number. I think those who understand geometric mean, arithmetic mean, clear. Then this is the formula of Fisher ideal index method. This is the formula of Fisher ideal index number. This is multiply. This is multiply side. So if you understand, this is multiply side. Go to insert. If you want to learn this, go to insert. Go to symbol. Under symbol, put the multiply sign. This is multiply sign. These things also you should be good with computers. I teach you computers, Word, Excel, everything I teach you. You do hard work, I'll give training for you for Word, Excel. You become expert in them. Just now I was taking classes for Kolkata schools, Kolkata Engineering College people. So I hope this part you understood, right? You understood what is Lesperus. You understood the formula for the Lesperus. Okay, you understood the formula of Lesperus. You understood the formula of Paasche, right? So if you multiply them, if you take the square root of that value, that we call as a Fisher ideal index number. Anyone, any doubt? Anyone, any doubt? Simple, guys, formula. I just write it down, okay? Make a note of all these formulas. If you want, I'll send you this Word document also. So just make a note of these formulas, because this chapter index number only formulas are there. Nothing is there. Very easy chapter. Only formulas are there. Little bit we need to remember. So you can see this. The Fisher ideal index number. It is known as ideal index number. Why? Because it is based on geometric mean. It is based on current year and base year. It confirmed test of consistency. So we'll talk about test of consistency. We have something called time reversal test. We'll talk about factor reversal test. So it follow those tests. Okay, so that's why the Fisher index number method is called ideal index number method. Okay, then next thing we'll talk about Dorbis-Bowley method. So if you do geometric mean of Lesperus and Paasche, that is called as Fisher ideal index number method. While if you do the arithmetic mean of Lesperus and Paasche, then it is called as Dorbis-Bowley method. So geometric mean of Lesperus and Paasche was the Fisher ideal index method, while the arithmetic mean of Lesperus and Paasche, that is called as Bowley, Dorbis-Bowley ideal index number method. Clear, everyone? So if you take the geometric mean of Lesperus and Paasche, it is called as Fisher ideal index number method. While if you do the arithmetic mean of Lesperus and Paasche, then it is called as Dorbis-Bowley method. Anyone, any doubt? this is, if you want formula, you say, sir, I don't want this geometric mean, harmonic mean. You simply give us the formula. So this is the formula. Again here, again the same mistake is there, which I corrected before. This is sum of P naught Q naught. Clear everyone? So arithmetic mean, you, so what, whenever you are solving the problem on index number, you just need to find Lesperus and Pache. If you do the arithmetic mean, it is Dorbus-Wally method. If you do the geometric mean, then it is Fisher ideal index number method. Then Marshall-Egworth method. If you follow Marshall-Egworth method, then this is the Marshall-Egworth method. This is the Marshall-Egworth method. This is into sign, okay guys? This is into sign, don't get confused. Clear everyone? So if I talk about Lesperus method, Lesperus spelling can be wrong. If I talk about Lesperus method, then your formula is sum of P1 Q naught divided by sum of P naught Q naught into 100. This is Lesperus method. If I talk about Pache method, the Pache method formula is sum of P1 Q1 divided by sum of P naught Q1 into 100. So you just find Lesperus and Pache. Okay, so geometric mean of, if I represent this with L01 and just if I represent with P01, so the geometric mean of Lesperus and Pache, this the geometric mean of Lesperus and Pache is called Fisher ideal index number. Geometric mean of Lesperus and Pache is called Fisher ideal index number, while the arithmetic mean of Lesperus and Pache, that is called arithmetic mean of Lesperus and Pache, that is called as Dorbis-Wally method. That is called Dorbis-Wally method. This is called as Dorbis-Wally method. So the geometric mean is the Fisher ideal index number method, while the arithmetic mean is called Dorbis-Wally. Here everyone. Then if you simply, there's something a Marshall-Egworth method. So what is Marshall spelling? Marshall-Egworth method. So if I talk about Marshall-Egworth method, then the formula for Marshall-Egworth method is sum of P1 Q naught plus sum of P1 Q1 divided by sum of P naught Q naught plus sum of P naught Q1 into 100. So please make a note of all these methods. You have to remember the formulas. Nothing else is there in this chapter. Only after remembering the formulas. Then you have Cayley method. Cayley has suggested the following formula for the construction of index number: sum of P1Q divided by sum of Q1 P naught Q into 100, where what is Q? Q is P naught plus, sorry, Q naught plus Q1 by 2. So this is the formula, sum of P1Q by sum of P naught Q into 100. The Q is Q naught plus Q1 by 2. Average of two quantity here we need to take. This formula is actually sum of P1 Q1 plus Q naught by 2. The sum divided by sum of Q naught into Q naught plus Q1 by 2. This value what you get multiply with 100. Any doubt, anyone? Anyone want to ask any question? Any question, anyone? So suppose this is the question, guys. Write down this question. Construct the price index number from the following data by applying Less method, Pashi method, Fisher ideal method. You want to try this, guys? So you can easily understand, guys. 2 years are given. So this year will be your base year. This year will be your base year. And this 2002 year, the older one, take the base year. So 2 years are given. So 2 years are given. Take this as a base year. This year, this will be your current year. So this you can write as P naught. This will be Q naught. This will be P1. This will be Q1. Any doubt, anyone? Kaylee, okay. Kaylee, very simple, Afra. Kaylee, the formula for the Kaylee index number, the formula for the Kaylee index number, the formula is sum of P1 Q divided by sum of P naught Q into 100. Where what is Q, sir? Q is Q naught plus Q1 by 2. So for every year, will for each product, we'll find Q naught plus Q1 by 2, and that will multiply with P1 and P naught, and we'll take the sum, and that will give us the index number. So if you see this for here, if I say what is the Q value after, so 5 plus 8, 13 by 2. 5 plus 8, 13 by 2 means 6.5. This is the Q. 12 plus 10, 22 by 11. Then 15 plus 12, 27 by 2, 13.5. Then 18 plus 20, 38 by 5, 19. Are you getting it? So what is P1Q? So P1Q will be 6.5 into 4. So that would 26. 11 into 4, 11 into 6, 66. 13.5 into 5. 13.5 into 5, that will be 675. 675, 67.5. 67.5, if I'm not wrong. 19 into 19 into 4.5. 6.5 into 4 is okay, 13 to 26, 11, okay, 66. 13.5 into 5 is 69.19. 19 into this will be 76. So just show the where it went. So this is 66, this is 67.5, this is 76. So the sum of P1Q will be the sum value of this. You got it right? Understood everyone? So we are doing this problem. Till now, anyone have any doubt? Any question, anyone? Anyone want to ask any question? Please ask me. Here everyone. Anyone have any doubt? Fine. So now we'll try to solve this question. So this is, you know that this is P naught, this is Q naught, this is P1, this is Q1. So you can find P naught into Q naught, multiply simply 2 into 8, 16, 5 into 12, 60, 4 into 15, 60, 2 into 2 into 18, 36. Are you getting it right? Simply multiply 2 into 8, 16, 5 into 12, 60. So 4 into 15, 60, 2 into 18, 36. So this is called P naught Q naught. Then you can find P naught Q1. P naught Q1 means what is P naught Q1? What is P naught Q1? How will you find P naught Q1? So 2 into 5, 10, 5 into 10, 50, then 4 into 12, 48, then 2 into 20, 40. Clear everyone? P naught Q1. That part clear? So the word itself telling you the meaning. P1 Q naught. If I want P1 Q naught, if I want P1 Q naught, P1 Q naught means P1 Q naught. 4 into 8, 32. 6 into 12, 72. Okay, then 5 into 15, 75. Then 18 into 4, 72. Do the sum, 251. Simple. the sum of this is 172. The sum of this is 148. Do the sum. Okay. Any doubt, anyone? Okay, very good. You did Afra very well. Okay. For others who have not done, I'm doing for them. So still, if you anyone have any doubt, you do the sum. No, these are the sum. These are the sum you got. Now P1 Q1 means 4 5s are 20, 6 10s are 60, 5 12s are 60, 4 20s are 80. Do the sum of that. Sum of P1 Q1 20. Now once you get this value, guys, once you get this value, once you get the value, so if you get this value, guys, if you get this value, if I say sum of P1 Q1, sum of P1 Q1 is 220. Okay, sum of P1 Q naught, that is equal to 251. Okay, then sum of P naught Q1 is equal to 148. Then sum of P naught Q naught, sum of P naught Q naught is equal to 172. Okay, so what is Lesper's formula? Lesper's is sum of P1 Q naught. P1 Q naught means 251 divided by sum of P naught Q naught means 172 into 100. Do this, get the answer. Pache is sum of P1 Q1. P1 Q1 is 220 divided by sum of P naught Q1 148 into 100. Do this. Anyone, any doubt? Okay, so after is telling Lesperus is 145.93 and Pache is 148.64. Everyone got this value? If you ask me what is Fisher ideal index number, 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 that will be under root of 145.93 to 148.64. So do this. Yeah, whatever the value you get, you can find that value. So just do that. So Les Perez is 145.93. Les Perez is 145.93. Les Perez is 145.93. Pache is 148.7, and the Fisher what you will get is 147.3. Very good, Afra. Clear, everyone? Anyone, any doubt? Anyone, any doubt? Any doubt, anyone? Very good. Other way also you can find the Fisher ideal index number by this way. Anyone, any doubt? So very simple. Now try this question. You have to find Dorbis Bolly and Marshall Egworth for this data. Do this calculation, everyone. Ayan is asking, so to get this answer, should we try all method? No, Ayan. Ayan, can you speak? So for this question, boiling, you know what is Dorbis boiling method? It's a arithmetic mean of Lesperus and partial. Marshall Egworth price index method. When I talk about Marshall Egworth price index number, the terms, no, the numerators of Lesperus and partial, you simply add them. The denominator of Lesperus and partial, you simply add them into 100. Okay, so that will give you Marshall Egworth method. Okay, so here we can easily find P naught, Q naught. This will be your Q naught. This will be your P naught. This will be Q0, Q1. This will be P1. So I can find the value sum of P naught, Q naught, sum of P naught Q naught will be 380. The sum of P naught Q1, that is 324. Okay, similarly, I can find sum of P1 Q naught is equal to 500 and sum of P1 Q1 is equal to 422. Once you get this value, now you can simply apply them in the formula of whatever the formulas of Boyle index number and Marshall-Edwards method, you simply put them, you will get both the values as the 131. Clear everyone? Any doubt? Any doubt, anyone? Anyone, any doubt, any question, please ask me. Do this question. Do this question. Question number 4. Everyone, do this question just now only. Everyone, do this question. Do it now, everyone. Any doubt, anyone? Any question you want to ask from me? So this will be the answer for this problem. We just need to follow the formulas which I just now mentioned. The formula for Lesperus, Pache, or Marshall-Edwards, or Dorbis-Boily, or Fisher ideal index number. Follow that formula, you'll get the answer very easily. Anyone want to ask any question before I conclude today class? So this much from the today class. Anyone want to ask any question? Any question, anyone? Fine, then if nobody have any doubt, then I like to wind up the class. Thank you, everyone. I'll see you all very soon for the next class. Take care. Bye, everyone.